Hi, in this video I'm going to be talking about Newton's third law. It was developed by a guy named Isaac Newton in the 1600s. Brilliant guy. I think as far as scientists go, him and Albert Einstein have came up with or devised the most big things, I would say. And that's in science. So Newton's third law is the third law of motion. It can be stated as every action has an equal and opposite reaction. And what that means is every time I apply a force to this notebook with my finger, a force is a push or a pull. So every time I push this notebook, the notebook pushes back with the same force, but in the opposite direction. So I push the notebook with this finger in this direction. The notebook pushes back in this direction with the same force magnitude. So I can show this with spring scales how it's true. If I just link the hooks up, and let's see if I can let me do this against my wall so you can see what it reads on the scales. So in Newton's, the blue scale is applying about a half of a Newton onto the pink scale. In the blue scale, let's see, it's going to be upside down. The blue scale the pink scale is applying about a half of a Newton onto the blue scale. So that's pulling. As far as pulling goes, for that side of the story, it also works with pushing. You can use some bathroom scales. You get two bathroom scales and push them up against each other, and you can see that the force will be equal and opposite. And a lot of times Newton's third law gets confused with something they have something called force diagrams. So let's say here's an object and you want to draw a diagram of every force that's being applied to that object. Let's say here's the force of gravity, and let's say that object is on the surface, it's on the ground, and the ground is applying a force back up against the force of gravity to make sure that that object doesn't accelerate in the vertical direction. These are not action-reaction pairs. This is not Newton's third law. This is acting on one object. This is all the forces acting on one object. Even though they are equal and opposite, they are not action-reaction pair. An action-reaction pair is whenever you have one object and another object, and this object is applying a force to that object, and this object applies the same force back as a reaction, equal in magnitude. This is two objects here. This is one object. These are all the forces applied to one object. And that's the difference between those. And Newton's third law is used all over in science. And as far as Newton's third law goes, that's all I have to share for now. And if you like the video, like, share, and subscribe. See you later.